We are in chapter 5, section 3. So this is the first section in the next unit. So here we're talking about perpetuities. So a perpetuity is an A sub n annuity, a standard annuity without an end date. So its timeline looks a little bit different. And we're going to call this A infinity because we make an infinite number of payments. So what I like to do at the end of my timeline is I just put a little arrow. You don't have to do that. I just think it makes it more fun. But again, we're going to have infinite numbers of payments. We can also have what's called a deferred annuity. So that's where we have A infinity deferred over here, and then A infinity would happen here, and then we make our regular payments just like normal. So we have the two types of kind of pieces. So this is where you put a bunch of money and then you let it sit for a long time and then it starts making regular payments, or here we just start making the regular payments like we would normally. So our equation here for A infinity, there's two versions. We can have R over I, or we can have R over 1 plus I to the n minus 1, where n is the frequency of the payments made in 1 year. Okay, so n here is not the number of periods. But the big idea here is that when the payment period or the payment frequency and the interest frequency are the same, then we use this one. So this is when interest and payments have the same frequency. Okay, and then for A deferred, A infinity deferred, it's going to be the same thing. It's going to be either this one or this one. Usually it's this one, so I'm just going to put that one in there. Times 1 plus I to the negative p. So the p is the same thing that we were talking about before, and here the key is that n plus p is always going to be equal to the number of periods, payment periods total. Okay, so that kind of helps you figure it out. And we'll go over an example of that here in a moment. But first we're going to take a look at example 11. So in example 11, we're trying to figure out how much to be deposited at a 4.5 interest rate in order to provide $7,500 each year beginning 1 year from now. If interest is compounded, and we're going to do it annually, quarterly, and continuously. Okay, so these are all going to be just a little bit different than what we're doing currently. Okay, so this here we want annual, so our timeline is going to look like normal. So we have A infinity here, and then a regular payment that goes on forever, 1 year, 2 years, just to get our idea. So here our R is at 7,500, so we can put that in there. So that's our R, our regular payment. And then our interest rate, little r, was 0.045, and that's annual. So that tells us that I is 0.045 over 1. And here we're compounding annually and we're depositing annually, so they match. So A infinity is just going to be 7,500 over 0.045 over 1, because again here they match. Okay, so here they match. So when we do that in on our calculator, make sure when you have more than one thing in your denominator, you put parentheses around it. So we get $666.67 rounding to the nearest penny. Okay. Now when we do it quarterly, it's going to work a little bit different here. So essentially what this denominator is up here is it's the EIR, that interest rate, so we don't have to worry about the P's here. Okay, we'll only worry about the P if it says like 5 years from now, or when it's more like that. Otherwise we don't have to worry about the P. Okay, so here we have our, really it's the same timeline, I'm just rewriting it. Okay, so A infinity is going to equal our 7,500, and then on the bottom here our R is the same, but I is quarterly. So that means that our I is going to be 0.045 over 4. And then our n is 4, because that's 4 times a year. So we get 1 plus 0.045 over 4 to the 4 minus 1. So that whole thing's in the denominator. So we need 2 sets of parentheses to start. And then again, end your parentheses. So here, this time we don't have to deposit as much because that money is doing the work for us. So we get $163,880 and 39 cents rounding to the nearest penny. Okay. Now if we do it continuously, our denominator is going to be similar to this, but again, that denominator is pretty much the EIR. So we have the same timeline. And here our R is still 0.045, and then we're doing it monthly, so our T is just, or our yearly, so our T is going to be 1 because it's annual. Okay, so our denominator is going to look different. So instead of it being 1 plus, it's going to be E to the 0.045 times 1 minus 1. So this was the EIR for that, so you can double check that formula. We first learned it in section 2.7, so that's review, because it's really the same idea. So we're going to take 7,500 and divide it by E to the 0.045 times 1 minus 1 and a parenthesis for a denominator. So this time we have to just input just a little bit less, and again we're going to round to the nearest penny, so it's going to be 162,944 and 79 cents. Let's go on to example 12.